section 5.1, we're going to be talking a little bit about number theory. In particular, we're going to talk about prime and composite numbers. Number theory is primarily concerned with the properties of numbers used for counting. In other words, we're not going to worry about 1/2 and 2/3 or the square root of 7. We're only looking for counting numbers, 1, 2, 3, 4. The set of natural numbers is given by this. I realized that when I exported my file into a PDF file in order to do the video, it every once in a while gives you some crazy symbols like that. Sorry, there's nothing I can do about it. I've tried to fix it, but nothing I do seems to work. So just something that we both have to deal with. Natural numbers that are multiplied together are called factors. So for example, if I have 2 times 12, then 2 is a factor of 24 and 12 is a factor of 24. There are other factors of 24, for example, 3 times 8 and 6 times 4. If A and B are natural numbers, A is divisible by B if the operation of dividing A by B leaves a remainder of 0. So, in other words, let's say, for example, I want to look at the numbers 8 and 2. So does 2 go into 8 evenly with a remainder of 0? Yes. 2 goes into 8 4 times. So we would say that 8 is divisible by 2. And the symbol actually would be 2 and then this, which is not a fraction bar, like that. So I'm not saying 2 divided by 8. That's not what this means. It says that what this symbol means is that this goes into that number evenly. The same way of saying that is B is a divisor of A, so we would say something like 2 is a divisor of 8, or 8 is divisible by 2. Two different ways of saying the same thing. For example, this is another example, we would write 12 divides 24, because 12 goes into 24 evenly with a remainder of 0. And we would also say 24 is divisible by 12. On the other hand, if we write 13 divides 24, this is not true because 13 does not go into 24 evenly with a remainder of 0. So, you know how if you have something that's not equal to, you put a little slash through the equal sign? Well, same thing here. If we say does not divide, we put a little mark through it. So 13 does not divide 24. A prime number is a natural number greater than 1. Notice I said greater than 1. 1 is not a prime number that has only itself and 1 as factors. A composite number is a natural number greater than 1. Again, notice I said greater than 1. So 1 is also not a composite number that is divisible by a number other than itself and 1. Examples of prime numbers, 2 is a prime number, 3, 4 is composite because 2 goes into it, 5 is prime, 6 is composite, 7, etc. And no, 9 is not prime, 9 is a composite number. Next one after 7 for prime number, I believe, is 11, 13, 17, etc. Fundamental theorem of arithmetic. This is so important to arithmetic that we call it the fundamental theorem. Every composite number can be expressed as a product of prime numbers in one and only one way. So what that means is that if I come up with a prime factorization of a number, it's going to be exactly the same as prime factorization for anybody else doing it doing it. Doesn't matter which method you use. You're always going to have the same prime factorization for each number. One method to find the prime factorization is called a factor tree, which you guys should remember how to do, but just in case you didn't, let's suppose we have the number 700 and we want to find the prime factorization. So one way to start is just to start with any two numbers that will multiply to get 700, like 7 times 100. I prefer to start with 2 and then go to 3 and then go to the next prime number, which is 5, but it really doesn't matter. You're going to get the same answer. So let's start with 7 and 100. So 7 times 100 gives us 700. And remember, when you come up with a prime number, you will circle it. So then we have 100. Well, what two numbers will multiply to get 100? Let's see. Well, 4 and 25. Neither 4 nor 25 are prime, but 4 is 2 times 2, and 2 is prime. And 25 is 5 times 5, and 5 is also prime. So the prime factorization, we would write it with exponents. So we would say 2 to the second power, because there's 2 of them, times 5 to the second power, because there's 2 5s, and 7. So 700 is equal to 2 squared times 5 squared times 7. This is the prime factorization. Now remember, when you're doing prime factorization, each of these factors has to be a prime number. We also typically arrange the factors from smallest to largest. It doesn't matter, but it's just easier. Okay, steps to finding the greatest common divisor of two or more numbers. First thing you want to do is write the prime factorization of each number. Second thing, select each prime factor with the smallest exponent. If we want the greatest common divisor, we want the smallest exponent that is common to each of the prime factorizations, and then we multiply those out. So I'll give you an example to see how that works. Pairs of numbers that have 1 as their greatest common divisor are called relatively prime. It doesn't mean that the two numbers themselves are individually prime, but if they do not have any common divisor, then or common divisor of 1, then we say they are relatively prime. For example, we look at 5 and 26. Notice 26 is not prime. 26 is not prime. However, 5 and 26 together are what we say relatively prime, because they have no common divisor except for 1. All right, let's take a look at the greatest common divisor. We're going to find the greatest common divisor of 216 and 234. So the first thing we have to do is find the prime factorization. And you can start with any number. I prefer to start with the smallest prime number, which is 2, but it's your choice. You can start with any number you want. 2 goes into 216 108 times. 108 is even, so we know that 2 goes in 54 times. And 2's are prime, so don't forget to circle them like I did. 54 is also even, so 2 goes into 54, let's see, 27 times. 27 is not even, but let's try 3. 3 goes into 27 9 times, and then 9 is 3 times 3. So we have the prime factorization of 216. We've got 3 factors of 2, and we've got 3 of 3 as well. So 2 cubed times 3 cubed. Let's take a look at 234, and we need to create the prime factorization. So again, it's an even number, so we know 2 goes in. And 2 goes in let's see, 117 times. Notice 117 is not even, so we have to try another number. And let's try 3. See if 3 goes in evenly. And 3 goes in there 39 times. And 39 is 3 times 13. So we have the prime factorization of 234, which is 2 times 3 squared times 13. All right, now, here's where we actually find the greatest common divisor. So what we do is we look at the factors of the prime factorization. So 216 has a 2, 234 has a 2, so they both have 2's. So I need at least a 2 to some power. Greatest common divisor. And they both have 3's. They do not both have 13, so I'm not going to use a 13. Now we have to check to see what power we're going to raise the 2 and the 3. What we're looking for is the first. And if we look at the 3's, we have a 3 cubed and we have 3 squared. Smallest exponent would be squared. So when we multiply these out, we have 2 times 3 squared, or 2 times 9, which is 18. Greatest common divisor is 18. All right, I'm going to stop here for part 1. I will start part 1 where I left off.